Okay, now that the digitizer is loaded, the first thing to do is to upload a PDF. So you hit this button, Upload PDF, and I'm going to select a Turbo Arrow, Piper Turbo Arrow POH that I happen to have. Okay, and it's loaded. And now the first thing to do is to add a graph. So let's pick a graph. And then we have a new graph item here. And we want a source image. So we're going to pick one of the images out of the PDF. So pick from PDF right there, and you can see the thumbnails come up. All right, let's move down. And want to expand this a little bit so we can see what we're doing. So you hit the expand button. Okay. So I'm going to start with the takeoff performance graph for 25 degrees flaps. So I'll press that and up it comes. All right. Now I'll set the name, which is flaps 25 takeoff performance. Okay. Well, actually, it's obstacle performance, and we'll call it that because that's what Piper calls it. Clearance. All right, there we go. All right. Now, the first thing to do, now that I have the graph up, is to first zoom in on the first graph that we're going to deal with. So I'm going to use these zoom buttons up here. You also have if you want to just make the whole thing fit, you can see what you're doing, you can do that. But the zoom buttons are very, very handy, and I recommend zooming in pretty much as far as you can. Okay. Now, first we have to set the bounds of the graph, and like most digitizers, you'll have to set points that represent the boundaries of the graph. Don't have to be too accurate here, but let's get started. First, let's set the bottom left origin, and that's here at -40 at the bottom. Okay, you see the little red dot. Next, for the x-axis, we go to +40. And then for the top, we're going to go to all the way over to one of the main lines, but also at 40, right here. Okay. Now we have to define what those points mean. So on the x-axis, the left-hand point is 40, -40 rather. The right-hand point is 40. And you can see there's 40 degrees of change between the major axes. So that means there are 10 increments, so that means each increment is 4. So we'll change the increment to 4. And now the rounding. And this is important because it's really telling you what the significant digits are here. And in a grid like this, I usually start somewhere between a 1/10 of the grid increment or a 20th. It depends on what's reasonable. Remember, the way this is being used is normally by a human kind of interpolating up this arrow you see here, and then kind of guessing where this comes in, and then again going over horizontally. So this is not the most accurate thing in the world, and having dozens of digits after the decimal point isn't going to do you any good. So for here, what we're going to do on the x-axis, since we're mostly going to sample on lines, we're going to do just half a 0.5 rounding. So that's roughly a 1/10 of the grid point. On the y-axis, Okay, the 0, you can see from the scale here, is 0. It starts at 0 and ends, we set it at 4,000. Okay, so we'll put 4,000 here. And each increment is 100. As you can see, it's from 0 to 110 slices. And we'll start at 5 for the rounding. Okay, then we'll hit initialize grid. And what that does, you can see, it pops up a grid. Now, most of these graphs have some skew in them. This one is actually relatively good, but there's still visible skew. And so let's show you. You can see I've done pretty good. The way I start making sure this grid fits the visible grid is you start at the outside of the grid and then you can change it to handle the warping in the grid. So I see this is actually pretty good. The lines, if you can see it, go right through the middle of the lines on the graph, out in the corner. But here it starts getting a little weird. So let's take this one. We're going to select it, and I'm going to use the arrow keys for fine to kind of move it in so that it crosses at the right point. Now I'm going to do the same thing at the bottom, and you can see there's a little skew here, so I'm going to move that there. And while I'm at it, I'm going to change the corner. This corner needs a little adjustment, and the corner's on the outside. Okay. All right, so now things are looking pretty good here, in the corner here. Good. Okay. Now, you need to go through the grid pretty finely to make sure that the grid accurately represents what's shown on the page. And remember, with all the warping and the skew. And the reason is because it's skewed, the grid has to match the actual grid lines on the image, because when you sample, you're going to sample against the nearest points in the grid. So those points that are near those lines have to be very, very accurate. So I work from the outside in, trying to make things line up. Okay, so this is pretty good. This isn't so good. So we'll go here, that yellow line. And you can see, even after I stop selecting, there's a little yellow highlight that you can see around where I've changed things. So you know where things have changed. See, this needs to be dragged down just a little bit. What do we got here? That looks pretty good. This is a little high. Okay. That looks good. All right. Maybe change here a little bit. And I can see this is off over here. Now you can see these lines are pretty lousy because they've been digitized and pixelated. So you're going to have to kind of make a guess as to where the actual line is. You can see some pixels on one side or the other and just trying to guess it. But you can see as I change things, the grid kind of warps to align things, and that helps a lot. Okay. All right. Now, I'm looking at that, and things, let's see, up a little bit here might help. Okay. Now, I'm being very, very careful aligning the grid to the image, because that's where all the accuracy comes from. Like I said, the points are going to be relative to the nearest grid points. So accuracy, especially around the points that are near the lines you're going to sample, is paramount. Okay, that's looking pretty good. Now you see this hide button here. I'm just going to hide the grid because I've got it down well. All right, now let's define the inputs. Now we can see there's one input, which is the outside air temperature, OAT, and the other input is the pressure altitude. So we're gonna, this is a multiple line graph, so we're gonna have two inputs. The X parameter is OAT, and this turns into a key in P tables, which is the output from this thing. And I always use camel case starting with low, lowercase for names. So on the first input, which is pressure altitude, we'll do that. Okay, good. Now, these things are specific over here. These limits are specific to how things outside the grid are going to be handled. So for OAT, if you're lower than OAT, we're just going to use the minus 40 value, and that's called clamp low. On high, you'll get an error. For pressure altitude, the same thing. If you're below sea level, we'll just use the sea level value, so that's clamp low. And if you go too high, it'll cause an error. The output name is distance, because that's what you're going to get. Okay. Now we'll hit start digitizing to take samples. All right. Now before we do that, you'll notice this panel on the right has a table starting. And you can see where the next point's going to be. And so what I like to do is I make my first sample on the left, right here, okay? And then I'm going to go all the way to the right. All right, you can see that the OAT value is from minus 40 to 40, so I've sampled that correctly, nothing to worry about there. And you can see by this red line that the line's actually straight. I don't need any more samples here, but I might adjust it just a touch downward with the arrow keys by selecting the point and then touching one of the arrow keys to move it around. And honestly, that's splitting the uprights right there, so that's pretty good. And you can see when I select a sample to move, the little yellow highlight moves. All right, that's the sea level one. So let's put in that value up here. Select it and I hit 0. Okay, good. All right, now we're ready for 2000. So I'm going to hit New Series right here. Put in 2000. And let's start sampling. So I put one at the left-hand side, got minus 40, perfect. And on the right-hand side, 40. And you can see from the yellow line here that this line is no longer straight. Okay, that's perfectly fine. Let's put a sample. I want to find something that's on a line, so I'm going to put one at 20 because this is obscured over here and I can't actually see it. Well, I don't know. We can judge it pretty well. Let's do that. Put a point at 20. And still, let's try one here at minus 20. And I think I need one at 0 too. Okay. And you can see I can sample at in between 2 points and it will properly sort them. These lines are all well behaved, so I don't have to worry about the x-axis wrapping around itself. So let's look at how the lines between the samples look, because everything between the samples is linearly interpolated. All right, so this looks like it's right down the middle here. maybe towards the top here. So I'm going to take this and go down a little bit. All right, that works. Yeah, pretty good. Maybe move this one here, the one at 20. Whoops, I hit 2. I can see that. That's a sample twice. You can see a 20 and a 20.5. So just double click this. Hit the delete key and it'll go away. Another way of deleting it is you see this little X here. You can delete this row. That'll work too. Okay, so let's move this around to 20 and down a little bit. All right, perfect. That's looking pretty good. All right, so we've got another line. One more time just to demonstrate. And I'll do 4,000, hit a new series. Again, 4,000. I'm going to start at the left, go all the way up to the right, and let's put some more samples in. We'll use the same algorithm that we did before, putting it at the 10s. And okay, that looks a little wrong. All right, and down a little, looking good. All right, that looks good. That could go up a little. All right, looks like I'm splitting the uprights here. Now you see this is a little bit more curvy here. If I wanted to, I could put another one here, say, capture it a little better, and that works fine. Okay, this looks about right. And I can go on and hit a new series, but until we're all done. All right, let's leave that alone. I'm going to go on to the next one, which is the weight adjustment. Okay. Now, this is a little unusual since the numbers go from 2,900 to 2,100, and there's a little trick here. So let me show you what to do next. Whoops. You can see I misspelled flaps. Let's pick that up, flaps. All right, now let's add another graph. And we know this is going to be, I'll copy this, and optical clearance weight adjustment. All right, I know what that is. All right, now we're going to use the previous image, so we don't have to load it again. I'm not going to import the calibration. We'll do that later. Just going to import the image from the 25-degree takeoff flaps obstacle. So I'm going to import it, and we can see we got the same image. All right. So now we are going to have to define the grid a little differently. Okay. So let's set the origin here at 2,900. The x-axis bottom right. So this is 2,100. Begins someplace it ends someplace indistinct. So what we're going to do is we're going to actually end it here, and you can see there 400 pounds for a major division. So this is 17. Okay. Now on top. Now this goes up to, let's go up to the 4,000 foot line again. Whoops, there we go. Top left. And that's this major one right here. Let's make sure we got the right one. Yep. Okay. Now, let's calibrate the grid. Let's set up the grid. Okay, the left-hand side is now 2,900. As I said before, the right-hand side is at 17 now, so the x-axis can go up or down. Right. So for 400 pounds, I have 10 divisions, so that's 40 pounds a division. So we're going to go 40 again here on the x-axis, and I'm also going to do 5 pounds, roughly a tenth of a point. Okay. On the y-axis, like before, it's distance, so it goes from 0 to 4,000 with 100. And I'm going to do 5 again. Okay, let's initialize the grid. Okay, so you can see it's roughly right. We got the increments right. So let's start at the corners one more time. Okay, I think this could be dragged down just a touch. Okay, that also could be dragged just a little bit so that things line up. Okay, on this side, let's move that in and down. You can see things line up a little better. And honestly, that's pretty good. Okay, now look at some of these major ones here. You can see things are off over here. So let's take this one and drag it in a little bit so that all the little minor ones line up a little better. Okay, on top here, same issue. Seems a little off. Okay. Now let's go in towards the lines themselves and see how things work. Okay, that looks good. That looks good. This looks a little off. Let me go up. Oops. Okay. Yeah, that's okay right there. This one looks high. I tend to find the worst one in a series just to see if I can, because that's the one that drags the other around with it. This one is off, you can tell here too. That's better. Maybe this one needs to come up a bit. You can see the skew comes in many subtle places. All right. These middle ones, that could use some help. Let's find the worst one. I'm guessing. Let's try here. All right, well, I need some more help over here. All right, that's looking better. Up here and there. Okay. Now I'm not going to try and get this perfect right now. This is, a waste of your time. So let's just leave it at that. But I encourage you to, this is the place where you really need to spend time. Otherwise everything else will be off. So let's hide the grid and set up the inputs. Okay, once again, there's two inputs. The x-axis is weight. The y-axis is distance. And the output is also distance. Okay. Now, we're going to use a little trick here. Remember, what you're supposed to do is, like this arrow shows, you come in from the left and you hit the point from the original, from the left-hand side. Let me zoom out a little bit. Okay. You're going to get your vertical position from this graph. This graph. And then you're going to go over horizontally and find a distance and basically go down until a weight. So what we're going to do is we're going to linearly interpolate along these lines here. But that means that if I come in at this point, I want to come in with this, and the weight's 2,900, I want it to come out at 2,900. So in order to do that, I'm going to say, click this button that says the parameter that you come into, the value of the first input, will be taken from the y value of the first leftmost sample. Now it's not the smallest sample because it goes from high to low, so it's the leftmost sample. And so we can click that box right here. Okay, and that'll take care of it. And you can see that in a minute. All right, let's take our first sample. So start digitizing. We hit the button right here. Do the left-hand one and all the way at the right. And we can see, oh, by the way, the X and Y value that your pointer is at is right up in the upper right-hand corner, right over here. So let's see. It's 2,000 pounds is that point that we were after. And 790. Okay, cool. Now we can see that there's some curvature to this, so let's try sampling in the middle. That's not good enough. Let's sample here. And maybe here. You can see this part of the line's a little bit curvier, so I took more sample. This part's pretty straight. So I'm going to edit it, just bring it down just a touch. I'll zoom in so you can see that a little better. Maybe one more. Nice. Split the uprights on that. Maybe this down a little bit. I think that's pretty good. Okay. We can see all these samples kind of make sense. So 2,500's here, 2140 is probably here. And we're a little off of 21. Yeah, 2140 is right here. Okay. There, and this, oops, I moved it, I think. Yeah, that's better. And this one, you can see it's highlighted. It's 23. And you can click up in this part too to highlight the various points if you want to make sure what's going on. Okay. Now let's do another one. All right. Again, new series. And we're going to start here. And you can see it automatically pops up with the right value and maintains it if things change. All right, we got 2,000. And we're going to do the same kind of thing. This one is actually pretty good the way it is, isn't it? So I think maybe let's zoom in a little bit more, see it a little better. Yeah, it's a little subtle. You probably can't see it on your screen, but there's blue lines here. I do think it needs a point in the middle here. And they're now fairly in the right. So you keep going like this, and I just really wanted to illustrate the use leftmost Y. Okay. All right, one more. Again, there's another trick here. Let's add the final thing, which is the wind adjustment, but we're going to do it in two parts because there's two sets of lines here. The first is the headwind component and the second is the tailwind component. So let's do the headwind first. So we're going to add a graph. I'm going to copy this and call it headwind component, headwind adjustment. All right, excellent. Now you can see that right here on top. It changed the order to keep it sorted. Let's again use a previous image. We're going to import the configuration, but not the calibration, not the grid. Okay. Now I'm going to do this really quickly and not talk a lot, but we're going to set the origin again at 0, the y-axis at 15, and do 4,000. Well, since it goes high, we'll go 5,000. That's okay too. Okay, done. The x-axis is 0 and the right is 5. We've got, in truth, since we're doing 15, I'm going to do something a little unusual. I'm going to say the increment is 5 so that I get a grid every 5, because all these lines are straight. I know that. So we're just going to do it that way, and we'll make the rounding 1, because on the x-axis I don't care. Y-axis goes from 0, and I believe we said 5,000. And the increment's 100. And like before, we're going to use a rounding of 5, and we're going to initialize the grid. Okay. So you can see what that did. It made a fairly coarse grid in the X thing, but it lets us line things up where we need to. Okay. So let's line up the corners first. Okay. And line this major up. That looks good. Everything lines up in the middle. We'll line this up. That's looking good. Looks right here. Here could use a little help. And that looks good. Now let's check in the middle. Yeah, that looks a little skewed to the left over here, so push it right a little bit. And this looks a little skewed to the right and up. Maybe move this one down too. Get the whole line. Okay. Any other places that, oh, this is up. Okay. Well, you get the idea. I'm not going to really try and fine tune it, but again, I encourage you to do that. I'm going to hide the thing. The grid. I'm not going to bother sampling right now. Instead, I'm going to show you what to do with the tailwind. That really helps. Okay, so I'm going to add another graph, hitting add graph. And let's see, I'm going to name it from the headwind adjustment. I'm just going to copy that in here and change headwind to tailwind. Okay, great. Now I'm going to hit use previous from the source image, but this time I'm going to set it to hit to use the headwind adjustment, the source from the headwind adjustment, but also import the calibration and grid. Hit the import calibration and grid, and let's get back here. And you can see we've actually reused the grid that we set up previously, so we don't have to go carefully do that again. It's already done. All right, so I'm going to hide it and zoom in, and now all I have to do is start sampling. So in this case, because we set it up that way, we're going to do 2 inputs. First parameter is distance and wind, and the output is distance, and start digitizing. And we know everything's straight, so we can just do the tailwind like that. Okay, I'm not going to perfect it, but you get the idea. All right. I'm going to now save my work. So you see here it says save project. First of all, let's change the project name. This is a arrow 3. I'm just going to call it a PA28 -201 arrow, I think it's 4. Okay, we'll call it 4. Okay, good. And we can hit Save Project. And I'm going to put it here, my other projects, and there we go. Now it's saved, and I can load it again. I already have a project that I've been working on for the Cessna 310. Let's load it. And we're going to do some tables now. So there it is. Okay. You can see I've already got some stuff here, but let's add a table. And we're going to pick an image from the PDF and scroll down. Let's expand. All right, here's a good one. Maximum performance takeoff distance. Okay, so you can see there's several different things on the same page here. It has the obstacle clearance distance and the ground roll. So let's just do the ground roll first. So let's call this maximum performance takeoff roll. Okay. All right, that's up here. Great. Now, in doing a table, the idea is to take data from here and drag it into the value panel on the right. You can see these little yellow highlights. I can grab a number, and in fact, if I hover over it, just should be able to, there it is, you can see the number. Because the app has a built-in OCR. It's actually better if you've pre-OCR'd it with a professional tool like Adobe, but this works pretty good. But it would be even more convenient if I could grab a whole bunch of numbers, especially all these numbers in a column. And to do that, we're going to use a region. You can also rearrange these panels a little bit. So you see this little stack thing here, and it'll put it on the top, and that sometimes is more convenient. Let's go back the other way. I think I like it a little better. Zoom it out just a little bit so we can all see it. And then we're going to select a region with tabular data. So to do that, I hit region here. And I'm going to drag a little region box around it. Now you can adjust this by just going back, and see the little arrows, and you can clean it up a little bit. So it doesn't have to be perfect. And now we're going to define cells that you can drag and drop. To do that, we're going to add a column separators here and here and here. And here, and there, and there, and there. Keep going like that. Now, just you can always adjust them like the region right here. Whoops, there's too many. So I'm just going to delete it by double-clicking. And we got it. Now, I will say sometimes when you put a line on the region, it'll sometimes get the region bar and interpret it as a letter. So sometimes you may want to have two of them. Just put one on the inside here and another one on the inside here, so the bar is excluded. That sometimes helps, and we'll see if that works. If not, all right. And then we'll do a row separator again. Can adjust it as required, and same here. Okay, good. All right, now you can see there's the ground roll. That's the output, so let's put that there, which is a distance. Okay, the first input is pressure altitude, And the next input you can see here is OAT. OAT. And one more, weight. All right, excellent. All right, so now we're going to add a new weight. And the first weight we're going to add, oops, so I got to go to select data before I start dragging. And you can see things turn blue for the selection area. You can see the 5500 I'm dragging here, and let's try dragging it into there. Whoops, there's some extras. Probably because it interpreted some of these pixels, but let's get rid of that right now. All right, perfect. And an OAT, let's grab that right out of there. OAT, we don't need the C. And the degrees, perfect. And now let's see if we can grab that whole column of pressure altitude. Whoops, wrong thing. Let's just grab the pressure altitude. There we go. Much better. All right, that did it pretty well. You can see there's some editing I want to do. I want to take that comma out, and I want to turn sea level into 0. Nice. And now I'm going to just grab this ground roll. Okay, perfect. Now let's double check. I'm going to zoom in to make sure I can read this right. Okay, 1040, 1140, 1250, yada, 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 1850, yeah, okay. You see, you have to check this by hand. That's a 5, yes, not a 6. Okay, good. Double check. Nope, that's a 6. All right, so it's really hard to read, but that's why we do it manually, even though the OCR said something else. Okay, good, but mostly right. 1300, 2880. All right, good illustration. All right, now let's do the next one. Okay, we're going to add another OAT, and that OAT is -10. And it didn't get the minus right. That's fine. And so instead of editing those old columns, I'm just going to cut using Command C on my Mac and then paste. And I will allow that. Okay, good. And now let's try doing this one. All right. 1120, 1230, 1350, 1490. Whoops, didn't do that. 1490. 1650. 1650, 1820, 2010, 2240, 2500, 2800, 3140. All right, not bad, not bad. But it illustrates OCR is not perfect, but you can get a lot of it in right away. All right, one more time just to prove the point. This time it's 0. I'm just going to type it. And I'm going to cut and paste this again. And now do this. See if it works here. Okay, 1200, 1320, 1460, 1610. And that. Yeah, it did it. Okay. Yeah, excellent. Now, I'm not going to do the other one, which is, I believe, 10 degrees. Instead, I'm just going to do another weight just to illustrate how to keep adding. All right. So we'll type in now 5100. And the first OAT is -20. And I'm going to copy these in again. Okay, nice. And let's get the -20. Okay, 870, 960, 1050. Nice. All right. Looks good. Okay. Now, I'm not going to go through the whole thing. you see, you get the point at how to do it. But there's one other trick I can pull. Down here you see this verification, and it really only verifies pressure, altitude, and the output. And we know that the distance is going to increase with pressure altitude. So I'm going to set the verification for monotonic increase. And we see everything looks good. But just to illustrate what happens when things are wrong, I could set it to monotonic decrease. And you can see things are only increasing, decreasing. And it highlights in red when things aren't decreasing in this case, but we want it to increase, so bingo. All right. I'm going to try something. I don't know whether the slope of that curve is increasing or not, but let's just try it, see what happens. Well, okay. What that means is that the delta between these, each point, for all of the points, the delta is increasing. That means the slope is increasing. So that actually makes sense physically. You can see if we did it decrease, it would all turn red. But you can use this as a double check on the numbers in case some crazy number came through when you cut it and you missed it. Okay, all right, that's all well and good. Now, that worked out famously. All right, so now what do you do with all this stuff? So let me go back to a graph that we did before, which is the left-hand side of this graph. And what you do when you're ready, and if you're just doing digitization, you can stop right now, save the file, and we'll do that right now. Save the project, and we're replacing it. And hand me the file and I can do the rest. But what I'll do is I'll go through each table and I'll hit View P Table. And you can see this is the new format P Table. And I'll copy to a clipboard and paste it right into the app. And if it's for V4, I'll just take the numbers starting from the A right here, and all the numbers are there. Okay, so in a nutshell, that's how to digitize things. I'm sorry this went down a little long, but I hope this helps you in the future. All right. And thank you for your help in digitizing.